Okay, here we go. Solving equations, tutorial number 1. We're going to look first at one-step equations, and I know that you did a lot of work on this in previous years in math, but it's always good to go over and make sure you're understanding things correctly. So an equation's about whatever's on one side of the equal sign has to be balanced with whatever's on the other side. So right now we start out with a statement that says x plus 10 is the same as 17. But we know that we want to solve for x. We want to get x by itself. We want to get rid of this 10. And we ask ourselves, how can we make 10 go away? Well, the only way we can make 10 go away is to make it into a 0. So what do we do to a 10 to make it into a 0? We subtract 10. We just made it go away, right? 10 minus 10, gone, 0, there's nothing there. But we have to remember that we're in an equation. And to keep both sides balanced, whatever we do to one side of the equation, we have to do the other. So if we subtracted 10 from the left side, we have to subtract 10 from the right. So we're going to go ahead and bring down the x. We're going to bring down our equal sign, and 17 minus 10 is 7. And here's our answer. During all these solving equations, I try to keep my equal signs kind of aligned because it just makes the problem look a little less chaotic. All right, so let's look at the second one. Once again, we want the x to be by itself so we can know, hey, what is x? What x makes x minus 9 equal to 20? So we want to get rid of the minus 9, and the way we do that is we make it into a 0. So minus 9 plus 9 is 0, but we have to remember we're in an equation. Whatever we do to one side, we have to do the other side. So negative 9 plus 9, you could put that in your calculator if you wanted to, and it equals 0. We bring down the x, we bring down the equal, and 20 plus 9 is 29. We could always, of course, plug our answer back into the original equation and see if that's correct. And with the easy ones, it's really easy to see how to do that. We'd plug 29 back in, and we'd say, yep, 29 minus 9 is equal to 20. We did find the right x that makes that statement true that we started with. All right, so now we see we have 4x equals 36. Now, in the first two problems, in the first problem we had x plus something, and the second problem we had x minus something, and now we have x times something. When we see a number right next to a variable and we don't see anything in between, there's no plus, there's no minus, that implies that there's multiplication in between. So 4x means 4 times x, and we want to get rid of that 4. Now, this time we can't subtract a 4. Because that's not going to undo multiplication. So we're going to undo this multiplication by doing the opposite. And the opposite of multiplication is division. So when we go ahead and divide by 4, does this make sense? 4 divided by 4 is 1, right? And 1x is just x, just like 1 apple is just an apple. But once again, whatever we do to one side, we have to do the other side. 36 divided by 4 is 9. So we are right now looking at one step where we get rid of whatever it is that's stopping x from being alone. So here we've got negative 2 times x. And to get rid of the negative 2, we have to do the opposite of the multiplication. That's division. We have to remember to bring that sign with us. That's not a 2, it's a negative 2, right? It makes sense, right? Negative 2 divided by negative 2 is 1, and 1x is just an x. Just like one shoe is just a shoe. We're going to bring down the equal sign, and we're not going to forget whatever we did to the left side to keep the balance of our equation, we're going to do to the right. So 16 divided by negative 2 is negative 8. So these one steps are pretty straightforward, but what's important about the one steps is that we're really getting the idea of we're working with an equation where we have to keep both sides balanced. All right, so here we've got x divided by 3. We want the x to be alone. We want to get rid of the 3. And so you're guessing by now, or not guessing, you're coming to a correct conclusion that to get rid of something, if it was a plus 3, we would subtract 3. If it was a minus 3, we would add 3. If it's 3x, we're going to divide by 3. So now if it's x divided by 3, we're going to do the opposite of division, which is multiplication. We're going to multiply by 3. Now, I don't know if you can see this, but if you put a 3 divided by 3 into your calculator, or hit that fraction button on your calculator and put a 3 in the numerator and a 3 in the denominator, hit enter, you're going to get 1. So once again, 1x is just an x. That's how we got rid of our 3. But whatever we did to one side, we have to do to the other. 12 divided by 3, either do it in your head or pick up your calculator. No shame in picking up your calculator. My goodness, my pre-calc kids pick up their calculator all the time. That's what it's there for. All right, let's look at 6. Now, this one you could do 2 different ways. When I went to school, this is how they taught it. So I'm going to teach it the way I learned it, and then I'm going to teach it another way. So once again, we have 2/3. Actually, I'm going to switch what I just said. I'm going to teach it the way I've been teaching it and then show you another way. So here we've got 2/3. We see a fraction, but then we see that it's being multiplied by the x. We could straight up just go ahead and say, well, I've got something multiplied by x, so I'm going to divide it. I could divide, but see how kind of crazy that looks? But we can do this. We can pick up our calculator. Here's where it's really important. Please, if you need to pause the video, pick up the calculator, hit that fraction button. And what I want you to do is, so we're going to have a fraction within a fraction. It's going to be a little bit crazy. So when you hit the fraction button and you get to the numerator, so here's the fraction button, right? When you hit this, and here you need to hit the fraction button again. So you put the 2/3 here, and then when you get to the denominator, put the 2/3 there. Hit enter, and you know that you're going to get 1, right? Because we're dividing something 2/3 by itself, 2/3. Anytime you divide something by itself, you get a 1, and 1x is, of course, just an x. Here, 18 divided by 2/3, pick up your calculator, use that fraction button. 18 divided by 2/3 is going to give you 27. So that's one way of doing it. Realize that you have multiplication and then divide, and that's a great way to do it. The second way to do it is to, when I see a fraction, and probably people my age see a fraction in an equation, they think about multiplying by the reciprocal. So when I see 2/3, I think about taking 2/3 and flipping it. That's what we call a reciprocal. You just take the fraction and flip it. And I think about if I flip 2/3, I'm multiplying by 3/2. See how when I multiply, I'm going to get a 6 on the top. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 is 1, which is x. So I could multiply by the reciprocal on one side and the reciprocal on the other. And that's also going to give me the 27. Either way. Okay, you can do this either way. All right, and that's it with the 1 steps. Oh, I take that back. So here's the deal. See how we have that negative x? A lot of people like to do this. They don't see a number in front of the x, so they're going to sneak in a 1 here. And I'll just rewrite it. Is this the same thing as negative 1x, the same as negative x? Absolutely. And if that helps you to know what to do next, then rewrite it that way. Oops, not divided by negative 11. It's over. All right, divided by negative 1. So then I'm going to have x equals negative 11. Now I'm done with the 1 steps, and yes, we're going to do 2-step equations. All right, so now we're going to do the same thing where we're looking for what do we need to do, what do we need to get rid of to get x by itself. There are 2 things here, right? Can you see that I've got the 2 to get rid of? And I've got the 4 to get rid of. What I want to talk about right now is I want to talk about order of operations. You know the order of operations, please excuse my dear Aunt Sally. Well, with equations, we're going to do it backwards. We're always going to look for, instead of looking for the exponents and the parentheses, we're going to look for the easiest thing to get rid of, especially if we don't have exponents and parentheses. So I'm going to look at the 4. This is the easy one. Okay, because addition and subtraction I always want to take care of before multiplication and division. So here we go. To get rid of a +4, I'm going to subtract a 4. Now, I'm not going to subtract a 4 from the 2x. I'm just going to subtract the 4 once from the left side and once from the right. And when I do that, I say, oh, who goes with that negative 4? 2x minus 4 doesn't go together. They're not like terms. So 4 minus 4, that's what we're looking for. We're looking for. Okay, so we got rid of that. We bring down the 2x. 18 minus 4 is going to give me 14. And now I have a 1-step equation where I have 2 times x. To get rid of the 2, I'm going to divide by 2. Whatever I do to one side, I have to do the other. And I end up with x equals 7. We can always stop. Plug that 7 back into the original equation. 2 times 7 is 14. 14 plus 4 is 18. That's a great thing about solving equations. You can always plug your answer back in and see if you have it right. All right, so let's look at this one. We're going to go ahead and look for the easiest thing to do first with a 2-step. We want to do addition or subtraction first before we do multiplication and division. Excuse me. All right, so here we go. I see the -4 and I want to get rid of it. So I'm going to do the opposite to make it be a 0. So whatever I do to one side, to keep it balanced, I have to do the other side. -4 plus 4, gone. So I bring down the 3x. -16 plus 4, please pick up your calculator, especially if I've got some students that do math really quick in their heads, and good for them, but they make a lot of mistakes. So maybe do the math quick in your head and then double check with the calculator. All right, and then we have 3 times x, and we're going to get rid of that 3 by doing the opposite, and we're going to do that to both sides. And so we end up with x equals -4. If we wanted to, we could plug that -4 back in and see that we have it right. All right, same thing here. Why am I always getting rid of a 4? Should I have thought of this before I made this video? It seems like every single time we're getting rid of a 4. All right, so let's go ahead. It's not always going to be that way. So let's go ahead and get rid of that +4 by subtracting 4 from both sides. It's gone. I'm going to bring down that -5x. See this negative sign? For some reason, when people rewrite, a lot of times they'll forget to bring the negative sign down with the 5x. They'll just write 5x. And of course, they'll get the whole problem wrong. So you really need to pay attention to detail. In math, very important, just like it is in life in general. Pay attention to the details. So -11 minus 4, if I pick up my calculator, I'll get -15. Now I have -5 times x. I'm going to do the opposite. So I'm going to divide both sides by -5. And I get x equals 3. So 2 steps are pretty straightforward. We're going to be doing either addition or subtraction first, and then multiplication or division second. That's always what we'll do when we have these 2 steps. Oh, thank goodness we've got, but there's of course a 4 in the equation. I must have had 4 on my mind when I made up these problems. So here we're going to get rid of the +3 first. We're going to subtract 3 from both sides. We end up with the x over 4 equals -24, right? -21 minus 3, if I put that in my calculator. Okay, x is being divided by 4, so to get rid of 4, I'm going to do the opposite of division, which is multiplication. Do you see how 4 is in the numerator, and this 4 is in the denominator? If we do 4 divided by 4, they cancel out. I'm left with x, but oops, don't forget, if I multiply the left side by 4 and multiply the right side by 4, gosh darn it, I do not have a calculator. Let's see, do this in my head. 4 times 4 is 16, carry the 1, that's going to be 96, right? And a -96. All right, so we could always plug that back in and see that we're right, but for the sake of time, we're not going to. All right, let's do this one. Once again, we're looking in a 2-step for either doing addition or subtraction first. So I look at the +8, I want to get rid of it, so I'm going to subtract 8 from both sides. I'm going to bring down my 1/5 x. That's -10. I have 2 choices here. I could divide both sides by 1/5, or I could multiply both sides by 5 over 1. Your choice. I'll go ahead and do it this way. A lot of people are just like, hey, they'll say, Miss Overby, it's 1/5 times x. Why are you going to talk about reciprocals and multiplying? I want to just divide. You can do that. I'm just telling you, dividing by a fraction is the same thing as multiplying by its reciprocal. All right, so here we go. And so we're going to do the same thing to this side. And that fraction cancels out. We end up with an x. And over here, if we pick up our calculator, we end up with a -50. So I think this is it. You never know. Let's see. All right, that's it. Thanks for joining me. Practice a lot, because although these seem easy, if you really know what you're doing with these easy ones, then the harder ones will be even easier. All right, thanks for joining me.